All right, AP scholars, we are about to embark on the exciting journey of polymorphism. This will be fun. So here's the story. You know what? Maybe you have this big array of people. We talked about how exciting that was in the last video. That we can store all these different kinds of objects that are in this sort of related hierarchy with the extends keyword in a single data structure. That's very efficient. Now imagine that I want to go and calculate all the students' grades that are in this data structure, in this person array called people. I want to go through, I want to find the average grade maybe across the whole school. Well, how would you do that? And that has to do with something called overriding. And we'll get into exactly what that is in a second. Basically, it's when a subclass has a method that has the same name as a method in its superclass. So let's just take a look for a second and notice where that happens in our example classes. It's going to happen if we look at student. This is person, here's student. So we're looking at the student class. If you were to look at these lists, we see one called calculate grade, which is a pretty lame grade. Calculating thing. It's like, oh, if you got greater than 65, you pass, otherwise you fail. But notice that student has this, but also undergrad has a calculate grade, and so does grad student have a calculate grade. They have these two subclasses, grad student and undergrad student, have overridden their superclasses calculate grade, because that's right here too in their superclass. So that's an example of overriding. When you write a method, hold on, I got lost. Yeah, here we go. When a subclass has a method that is the same, I should say has the same name as a method in its superclass. That is exactly what overriding is. And actually, it's pretty fantastic. It's going to basically work the way we want it to work, as you might imagine it. So in this people array of person objects, when we confirm that, it's true that we might have things that are just general people. Pardon me. Whew. Getting sleepy. We might have just generic people that don't have any calculate grade, but let's assume we don't for a minute. It's all just students and undergrads and grad students. So you can just tell them to calculate grade, and they will figure out what is the right method to call that is appropriate for that object. You don't have to have different calculate grades for student and undergrad and grad student. You can just call them all the same name and override them. And then when you call calculate grade, on any of these, it'll figure out which is the right one. That's called polymorphism. So polymorphism is the mechanism that Java uses to choose which overridden method is the one to call. So I know I skipped a slide. I'll come back to overriding and its details. But here's some examples. Here's some student variables, A, B, and C. One has a student, one has an undergrad student, one has a grad student. Guess what? If you say A.calculate grade or B.calculate grade or C.calculate grade, it will use the correct version according to what object is actually stored inside of these variables. I know that the type is student, but the actual object's type that is stored inside, in this case is student, but in this case is undergrad. In this case, it's grad student. So polymorphism obeys what is the actual type of the object that's stored, not the variable's type. So that allows you to have these container variables that can contain any kind of student, and you'll still be able to call the correct calculate grade. This is great for an array list of students or an array of students or a 2D array of students or whatever it is you have, because then you can just tell each one to calculate grade, and it will pick the right one, even though the type of the variable or the type of the data structure is of the superclass. It can still figure out that, wait, actually I have an undergrad here. I'll use the undergrad's calculate grade, or grad student, or whatever it is. So again, that's called polymorphism. Polymorphism. I'm going to go back to this slide. Polymorphism describes the mechanism Java uses to choose which overridden method to call. And that mechanism is it looks at the object's type, the actual object's type that's instantiated there, not the variable's type. What's going on? Stop, Max. So let me say it again. The type of the variable or the data structure doesn't matter. It's the type of the thing, the object that is instantiated that matters when we're worrying about what overridden method to call. That's the key right there. Let's go back to overriding and get all the gory details about this. We already mentioned the first point. So the second point is you can override private or public methods, but they must remain the same. They have to stay private or have to stay public. Can't change that. And you cannot override static methods. That is not allowed. And we already talked about this. So yeah, that's polymorphism. So you might be like, oh, okay, great. Now this could be a question right here. What's going to happen? What is the resulting what's going to happen? Which calculate grade will be used? And again, you just look at the type of object that is stored there, not the variable's type. So dynamic binding is a term that is basically saying, when does polymorphism happen? Does polymorphism happen? Does it happen when you write your code and compile it, or does it happen while the program is running? So polymorphism happens when the program is running. It does not know what calculate grade to call when you compile. It will figure that out while the program is running. It will bind the correct method to the object dynamically. And dynamic always means while the program is running. So which calculate grade gets called at compile time? Java doesn't know. It figures it out dynamically when the program is running. So that's the story. Basically, overriding is not a compile time type of thing. It's a runtime type of thing. So you might be like, okay, who cares? Dynamic binding, great. I'll write that down. I'll remember the term. So, I mean, yeah, that's fine. And the AP exam requires you to do that for sure, to know that term. But here's where that matters. Look at this method here. Look at this method. It's called calc, and it takes a student as a parameter, and it says s.calculate grade. I don't know what it's doing with this method. It probably should do something with it, like print it out or something, but okay, whatever. How could we possibly know at compile time what this is going to be? This program might have like user input, where a user gets to select the student and print out their grade. Maybe it's like a gradebook software or something. At compile time, we have no idea what the user is going to choose. So it's so important that polymorphism is dynamically bound. In other words, polymorphism isn't decided at compile time, it's decided at runtime, because then you have freedom to write code like this, where users could call this method through whatever interaction they have. Maybe they're typing in things in the command line, maybe they're clicking on buttons in a graphic user interface. But that gives it the freedom to not decide until those things happen, until the user selects those types of things. It keeps it open and isn't scripted from the very beginning when you compile. So that's important to understand, that's when this happens. And that's why it happens at runtime, so that a method like this can exist and stay flexible and adapt depending on the situation. And it will always call the correct calculate grade no matter what gets sent, as long as it's a student or an undergrad student or some kind of subclass of student. So that makes you probably wonder, hey, is there something called static binding? Are there things that are bound at compile time? And yes, there are. It's a little bit neither here nor there with this conversation, but because we mentioned dynamic binding, I thought it might be a nice time to also just say, hey, so what is statically bound? Another word for this is early binding. And you could also call this late binding, the dynamic binding. But basically, static binding is all about overloaded methods. And it's very easy to confuse overriding with overloading. Yeah, the word over is in there, so it's going to be a little tricky. So what's the difference between an overloaded method and an overridden method? Basically, overloading is when you have two methods in the same class that have the same name, but they'll have different parameters. So we saw it, for example, back here. Here's a good example of code from our fraction class. Remember fraction? That was a good time, say. We have a constructor that's called fraction, and another constructor called fraction, and another constructor called fraction, and a copy constructor called fraction. We have all these different fraction constructors. They all have the same name, but you notice they have different parameter lists that we send them. So that's what's called overloaded. We overloaded the fractions constructor. We made many methods of the same name but different parameters. So that's an example of overriding, and that is statically bound. So in other words, when we compile, Java figures out which overloaded method we mean to be calling. That doesn't happen dynamically. It doesn't happen when the program's running. It's already determined. So yeah, so that's the story there. Overriding, however, the difference between overloading and overriding, that has to do with subclasses having the same name as a method in a superclass. So that's how you tell the difference. Overloading, it's the same class, two methods in the same class with the same name. Overriding is two methods in different classes, where one is a subclass and the other one is a superclass. That's the difference. Overriding, overloading. Does that make sense? I hope it makes sense. If not, please bring your many questions to class and we can discuss those and figure out exactly what's going on with overriding versus overloading. We can take a look at some more examples as well if you wish. That might be helpful. So we'll see what you think about that. Let's go and see something about the super keyword. Super. You can actually call super. It's great. It seems so positive. Wow, everything's so super. Super is a keyword, and it has sort of two uses, and it can help you to, access code that is higher up in the tree. So in other words, if I go way back to the second slide, the super keyword in student can allow you to access things in person. Pardon me. Sorry. That otherwise is locked away in person. So for example, you can use it to access constructors of your superclass. That's one of the things you can use it for. Remember that constructors aren't inherited. So if you want to access your previous your superclass's constructor, the superclass is what lets you super keyword, is what lets you do that. The other thing is overridden methods. So in an overridden method, we already know that there's this thing called polymorphism. There's a slide with that word on it. There's this thing called polymorphism that will automatically make sure that the subclass version of that overridden method will get called if it's actually a subclass object. So how would you force it to not do that and choose the superclass? Or how could you make it a blend of the two? Maybe you want to use some of the superclass and add some new things onto it. So again, the super keyword is there for you for those things. I'll show it to you. We'll go back to it. Here's the super keyword. So for example, if you wanted to call the superclass's constructor, and you would do that from within the subclass's constructor, by the way, then you could call it like this. or like this, depending on what sort of parameters it takes. And you could choose which one to call if there are more than one. So you can call the superclasses constructor from the subclasses constructor. And you should know that you can't put any code before this. This has to be the first line of code in your constructor if you want to do that. So that's great. One of the reasons you might want to do that, actually I'll leave this here, is if I go back to that code, remember that private variables can't be directly accessed, right? So in your student constructor, you can use the super keyword to call person's constructor to take care of those inherited values, things like name, age, and social insurance number. Because I can't directly access them. I can't just say, like here I'm saying my grade because it's my grade is just a variable, an instance variable, so I can access that, no problem. But I can't directly access these things. So I already have a constructor that directly accesses those things, so I can just call it here. And I'm using the super keyword to say, hey, person, can you please deal with this? Please call your constructor, construct these things, deal, assign those variables, those values. So that's how that works. That's a nice time-saving technique you can use. And let's go back now to the slideshow. That's here. You can also get your overridden methods to call your superclasses version of that overridden method. So for example, if a subclass to student said super.calculateGrade, that would call student's calculateGrade method. So it's useful for calling things in an overriding situation. And I have an example of that too in our code. An example of that is, it is here it is. In the grad students, notice that calculate grade, the first thing it does is it says super.calculateGrade. So in other words, it uses the student calculate grade, the one from the student class. So that's the 65 or over. And then it adds on additional code. So you can get passed with honors if you get over 90 or over. But otherwise, it uses the same calculations as your superclasses. So we can just call the superclass. You might be like, well, I could just type that code out, no big deal. Why do I need the super keyword? That's fair. Like sometimes it's simple enough. But even if it was, it's still nice to connect them together. And the reason is because, let's say, where I was a student, let's say this calculate grade, this 65 or over, something changes in the world and they're like, this is terrible. We shouldn't be passing people who got 66%. We need to get these tighter. So one thing that's nice about this is you can change it here. So I'll say I change it to 90, we'll say 80%. So now students only pass if they get 80 and above. Well, if you change it here, then it's automatically going to get changed down here when I say super.calculateGrade. Oh, I said grad. Sorry. It should be grade. But isn't that nice that it has this automatic updating as a result? If I coded it in two different places, I have to change it in two different places. And that's kind of tedious. Two different places is not a big deal. But, software can get huge. And you might have to code this in many different places. This is just an example, a small scale example. But that could become extremely powerful if you have a huge amount of classes and a complex web of hierarchies. So you can see how using that super keyword will be efficient for maintaining your code and building code that can grow without being too painful to try to maintain and improve in the future. And that's a major goal of object-oriented programming, is to facilitate big software, creating large-scale software, and making it possible to grow that software and to maintain that software as it ages. So, folks, that's a lot. We got one more thing. Downcasting. Downcasting. Oh my. Oh my. So downcasting is, I joked about it being as the kind of the end boss of AP Computer Science. It's kind of a trick question that can trick a lot of students. So take a look at this example here. So consider what happens when we call non-overridden methods. And that's the key. Really important to know this is the key. It seems like it's going to be a situation for polymorphism, but downcasting is actually a situation where it's not polymorphism because the methods aren't overridden. So watch out for that. If you see a methods in a polymorphism-like situation, but they're not overridden, then downcasting is happening, and you need to pull out some downcasting moves to make it happen. So here's a good example. So we have a student variable called S, and we're going to put a grad student in it. And then I'm going to make a grad student variable called G, and I'm going to put a grad student in it. If I say s.getID, or if I say g.getID, we have a compiler error here. So s.getID, but for some reason g.getID, that's working okay. But what if you, so I guess the question is why? What's going on there? So let's go take a look. So let's go to those classes. Notice that grad student contains this getID method, right? Because grad students apparently have a special grad ID. I don't know what that is, but we'll just go with it. This method only exists inside of the grad student class, so it doesn't make sense for a student to be able to do that. So let's go back and take a look at the example again. So getID doesn't work from a student variable. And you might be like, well, wait, I thought there was this thing called polymorphism, where it doesn't look at the type of the variable, it looks at the type of the object that is contained inside of it. And that is true, there is that polymorphism mechanism, but that's for overridden methods. getID is not overridden. It only exists in the grad student class. So that's where downcasting comes in. Does that make sense, everybody? I don't know. It's always very complicated, but the difference between this and polymorphism is, again, getID is only in this class. It's in the subclass. It's not in the superclass. It's not overridden, and therefore polymorphism doesn't apply. So you cannot do these nice polymorphism type things. And in those grade 11 and 12 processing projects, we went to great pains to make sure that this never happened. We would make act and show functions, for example, that were blank or empty, and then just so that they could be overridden, so that we wouldn't have to worry about downcasting. Even though it was dumb to have those things there, it didn't make any sense for maybe a generic object to have a show function or something, but we would put it in there so that we could use polymorphism and never actually have to worry about downcasting. But you know what? Professional software sometimes doesn't want to be janky that way, and so maybe they're not going to code it that way. So in other words, what do? So this is how you downcast. So, so say we have a student object that contains a grad student, and we want to get the ID of that grad student, then we have to do this. This is a downcasting. So we are casting, it's kind of like when we used to cast a double to an int or something. We are casting this variable to this type. And this only works if we actually have a grad student in there. So we'll have to look at the instance of keyword. We'll probably do that in class, and that'll be fine. And then you wrap the whole thing in parentheses, and then you could do .getID. Ugh, so bad. It's so gross. The syntax is not pretty. But there's no other way to do it. Because if it's not overriding, then polymorphism can't help you. So you have to downcast in order to get this this getID to work, so that the student variable can actually behave like a grad student. Wow, downcasting. We'll see some examples of this in class um, on Friday, and hopefully, when you're confronted with it, and you're like, "Oh, look, it's a it's a situation where it looks like polymorphism, but I'm not actually using an overridden method," you'll remember to use the downcasting. I think it'll be a challenge, but it'll be okay. Well, folks, there's only one last thing to talk about. I think there are technically other things to talk about in this slideshow, but they have been removed from the AP Computer Science curriculum. They were things I used to teach, but you don't need to know them anymore because they're not on the AP curriculum and they won't be on your test. And they're good things to learn, but we'll not worry about it right now. Maybe we'll learn about them after the exam. But the object class is definitely on the exam. It is the universal superclass. It is the superclass of any object you have ever written, any class, I should say. You don't actually say extends object, but it does. It's all classes secretly extend the object class. So that's pretty great because then you can make an object variable and you could stick anything in it. You can make an object variable and stick a array in it. You could stick a string in it. You could stick a fraction in it. You could stick anything in an object variable. So it might be kind of handy to have an object variable at some point. It would allow you to do some interesting stuff. But why? what is the point? So the object class has some nice things. For example, it has the toString method. Remember that special method in object-oriented programming that converts, or it basically turns an object into a string when it's in a string context? So for example, if you wanted to print out a fraction, we had a toString method that automatically got called. So that's originally something from the object class, and we actually override it every time we write the toString method. Isn't that great? We override the toString method every time we make a toString method, and that's part of where its mechanisms, because it kind of seems like magic. It's part of where its mechanisms are kind of built into every object, because secretly every object is extension of the object class. Also, it contains the equals method. So you can use the equals method. We see that with strings, but you can use it with fractions. I think we built that with fractions as well. So the equals method is also contained inside of there. And so here's some examples, some fun stuff where like you can have an array of type object, and you can have anything go inside of there. You can have a parameter that is of type object, and it would just take any object. It doesn't matter what it is. It could take anything and go from there. We'll have to talk about the instance of keyword. That's kind of the last thing to talk about. It's a useful piece of code that we've used in programming 11 and 12, but we'll use it on Friday as well. So anyways, AP Scholars, thanks for listening about all this stuff. If it seems like it's kind of spinning in your head and not 100% making sense yet, excuse me, then I think looking at some concrete examples, I mean, we did look at examples, but doing some questions where you're kind of forced to confront, do I understand this or do I not, will at first be terrifying, but then as you discover what the answers are and come to understand the answers, I think that's when you'll start to feel confident with this. It won't really make 100% sense just listening to me talk about it. So thanks everybody for doing just that, and I look forward to showing you next class some more information and give you the chance for you to test your understanding of this stuff and then give you the feedback necessary for you to sort of come to a better understanding. So we'll see you then. Thanks everybody. Bye.